Hello everyone, welcome all on Data Phoenix webinar. Today we speak about memory for LLM, and with us Sergio Prada. He is the co-founder and CTO at Metal, and he will talk about how use Metal with your LLM chatbots and using short and long-term memory. You can ask the question using Slander. The widget is under our video on our website. So please write your questions, and at the end we will answer for all your questions. Um, yeah, and now, Sergio, your stage.
Thank you so much. Thank you for having me here. I'm excited to talk about memory and a little bit about metal. So let's get started. First, I wanted to introduce myself. I'm Sergio. I've been working. I started metal early this year in January, and so far we've been working with LLMs. It's been a great journey so far. It's really exciting technology. Um, and as the technology evolves, there's been a lot of new pieces of the stack that have new types of problems in software that are really interesting. And I'm going to speak specifically about memory in the context of an LLM, not to be confused with a memory resource in a computer or a server. So let's get started. Um, So first, the agenda, we're going to discuss what is metal, what is memory, what memory techniques are out there. Then discuss a little bit about the production trade-offs that are necessary in order to figure out what solution you want to follow. And then finally, I want to share a project that we've been working on. It's an open source server called Motorhead that tries to solve some of these problems. So let's start with what is Metal. We started Metal in January as an embeddings as a service platform. So we helped developers generate embeddings and store them in a vector database, and then on the other end, provide them with tools to very easily index and retrieve those embeddings. And the the platform has definitely evolved ever since, and now we're growing a little bit in other parts of the stack like observability, ETL, and file processing, OCR, everything around chunking, um, in attribute extraction, metadata augmentation, and so many more things. And our idea is that we want to be enablers. We want to help the other developers build these applications, and at the same time, while we're working with larger companies, we can learn how to create new things to evolve the platform over time. So that's kind of our framework, and so far it's been great. And just to explain, like in detail, how it does it work and what do we actually do, we have ways of processing data. So we accept any data type that you have. It could be just raw text or a PDF or a CSV or a spreadsheet or whatever. And we process that data. We have ETL kind of for specifically for like LLM workflows. So we run OCR, we chunk all the data, we make sure that those chunks make sense within the scope of the task that you want to do. We also extract all the metadata required, and then we generate all of those embeddings. We store them in a vector database. And then on the application side, we provide you with all the endpoints that you need, APIs, SDKs, so you can run your workflows, you can run your RAGs, your chats, everything. And then finally, the third piece is around observability. So we keep track of how the indices are being used, how much data is being processed, as well as what is the relevancy score for each one of the queries. And so it provides like the full feedback cycle so you can iterate really quickly. And we provide those primitives for you to test, deploy, and quickly iterate your applications. So today, some of the things that we are doing in production, we're working with financial services, analyzing large amounts of data, extracting attributes as well, extracting things from tables such as specific revenues in the specific times um, for any type of document. We're also working with advertising companies, helping them streamline their RFI process, and then finally insurance, comparing contracts, and so on. I just wanted to give this basic baseline into Metal and what we could do, and now we can start talking about memory. So the first thing that I wanted to clarify that I think I did at the beginning is memory here is in the context of an LLM specifically um, in a chat application, right? If we take LLMs as is, they are really stateless models. So what the stateless really mean here is that every time we interact with it is like it doesn't have any previous knowledge of any other interaction that we've had. And here I have a very basic example. If I'm chatting with an LLM and I say, hello, who's Dave Mustang? And it responds who it is, then I do a follow-up question. In one end, we could say it understands the previous context, the message history, and then the other one it doesn't. So you can think of that state as like an additional um, wrapper around the LLM to make it really useful. And that's really what ChatGPT is. ChatGPT is just simply an LLM model, GPT, and wrapped around some sort of state, which makes it extremely useful. And so that's the type of that's kind of that's the memory we're talking about here. So the second thing I want to mention is that memory has to be thought of as a resource. Um, so just like a limited resource in a server is memory and CPU, in these applications, memory as chat history is actually a really important limited resource. And that limited resource is really the context window, the size of the context window. And the size of the context window is simply the number of tokens that you can fit um, to prompt an LLM, right? And since we need to store all of that state there, it's really important that we select what is the best possible thing to fit in that context. And that is probably one of the hardest challenges when building one of these applications in production. Um, because as you will see, it really requires a lot of prioritization and requires a lot of effort into understanding what is necessary and what is not. So the next question that a lot of people always ask is, so why don't we just increase the context window, right? Isn't that just easy? And it would just simplify a lot of the applications. It would certainly would. The problem, though, is that the performance of the LLM decreases when more context data is given. And there's this paper, Lost in the Middle, that actually proved a lot of interesting things. One of it is that if more data was given to the LLM to ask a specific question, the accuracy went down. And if it only makes sense, right? If you give an LLM a very specific question with the very specific context to get the answer from, it will probably be correct. It will more likely be correct. But if you give it a lot of noise and a lot of data that it really doesn't help, then uh, there's a probability that it will fail, of course. Um, and so selecting and prioritizing what you put in the context is one of the most important things you can do to improve your LLM application. Another interesting finding from this paper is that the position in the context, the place where the 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 data that you want to influence the LLM with, the position in the context window also matters as well. And that's actually what inspired the name of the paper, Lost in the Middle. They prove that at the beginning and at the end of the context, having the pertinent information to answer the query um, had a higher probability of success than having it in the middle, which is really interesting finding. Um, and so, how do we maximize this limited resource, this memory, this context window? How do we make sure that we're using it at its fullest? So now I want to share like basic techniques to maximize this and the kind of the pros and cons of each. So the basic, simplest approach you can do is just have a rolling window, right? And so that basically is you have the back and forth between a user and the LLM, and when it reaches a certain limit, if you want to keep it below that context window, then you just basically pop off um, the extra messages. Obviously, it's very simple, very easy to implement. Really, the problem here is that the all the information will be lost, and it's suboptimal. But it's a really good start, really good place to start if you're just wanting to write a quick chatbot. The second approach, it's a little bit more interesting and involved, but it requires you to do incremental summarization. So how this works is you have a list of messages. Once you've reached that a limit, you pull off a set of them and you generate a summary. And now you could have previous summaries, so then you would combine summaries over time. And this is really useful because it kind of gives like a general context of what is happening in a back and forth with an LLM. But it definitely has some issues. The summarization will always be a lossy process, and it also requires a call to an LLM. So it will be more expensive than just simply having a window. Um, but um, but having a call to an LLM also provides you with enough enough ways to control how the summary is going to be generated. And that is useful because when you have that control with prompting, you can ensure that your application is generating and summarizing the information that you need. So, for example, if I have a chatbot in a knowledge base or a CRM, and I want to keep track of that history using incremental summarization, then I can prompt specifically to always keep track of what is the context reason, why is the user reaching out to my application. So you kind of steer the summary into a specific guide, and that this is kind of related to the next technique, which is custom state management. So following that that idea of steering the summary to a specific use case is really interesting because it opens the door to more options. Why don't we just simply start storing a specific state um, with specific attributes and just guide the prompt to always accumulate this data? So a good example of this is imagine having a data store where you define a specific set of attributes, and then you would update those attributes as the conversation flow is going. Um, the problem, obviously, is that it's very complex to set up. You have to really understand what you're doing. You have to know how to use functions, how to generate structured output, um, and it requires multiple calls to an LLM. And there's a paper that just came out last week called MemGPT, which takes this idea even further and essentially tries to solve this issue around memory by combining an external data source um, and then kind of replacing the memory, the state that you have right there in the context with OpenAI functions or functions in general, and kind of like evolve that memory object over time. I highly recommend checking that out. And an important part as well is that mem- memory within an LLM application is only one part of the pie that context window requires. The other piece is also external knowledge. And so if you see that limited resource of the context window, uh, you start noticing that you have to share it with other things, right? So one is the chat history. You want the LLM to understand that this is like a back and forth. The second one is additional context from very old. If we have a very long chat, then that there will be additional context there that you will need to keep track of. And then finally is external knowledge, which is very important. It's the way you ground these LLMs. It's the way you do chat with my ex, right? So in the CRM example, if it's just as important to know who the user is, as well as what is the current conversation about, and then finally what the company is actually, what are the services of the company that this chatbot is interacting with. So managing those three things at the same time is why this is such a complex problem. um, and I mentioned that because um, it brings the idea to rack, right? Which is the technique where we take all of these documents, we break them up into relevant pieces, and then we generate embeddings for them. We put them in a vector database, and now when the user asks a query, we vectorize that query as well. We look for all the relevant data, and then we combine that into that external knowledge in the context window. But we can do the same technique for our message history, right? There's really nothing stopping us from just using this same technique for just chat history. And this is kind of like the long-term memory approach that a lot of people are using. And normally how this works is you have a back and forth, you have some sort of process in the backend where you receive every message, you vectorize it, and then you store it in a vector database. And now the next question is, wow, when do you fetch that? When do you fetch the closest messages to the query that you're asking? Is do you do it every single time, or do you do it under specific conditions? That is really also part of the challenge here. A lot of people are using routers and other types of technologies here and gateways to figure out when to do that. but this is definitely another technique that can be used. And so what about production? So in production, the deployments that we've done with customers really have three main priorities. And these three priorities will guide what techniques you could use in production. One is always going to be reliability. Second, scalability. Not every chatbot um, has to have 100,000 concurrent users, right? Uh, Not every chatbot has to have 1,000 concurrent users, right? So there's a lot of there's a lot of techniques to improve that scalability, specifically if there's no identity. So if the bot is not aware of who you are, there's a lot of caching that can be made. There's a lot of other things that could be built. And then finally, what is the user experience that you're looking for? Um, that is also a massive driver, right? Because if you really don't care a lot about identity, don't care a lot about long running history, or maybe the specific use case is a chatbot for documentation, then a lot of these techniques are really not that important. I would just use a rolling window. Now, if you have if you're building like a game and you want to interact with the user and remember everything that that user is doing, and that game could go for days, then some of these techniques might actually make more sense. So if you basically plot a one dimension of scale, then you could literally stack all of these techniques, right? The rolling window, it's essentially infinite scaling. Um, then RAG, of course, because these vector databases are um, the like when I say infinite, obviously it's not infinite, but you can scale it really, really well. Um, Incremental summarization, I would say, is even less scalable than RAG because you need to have this call to an LLM. And then finally, custom state, which is obviously the hardest one because it could rely into in multiple calls to an LLM. And so I wanted to share Motorhead, which is a open source project that we at Metal started. And this is specifically aimed to solve this memory problem. And so how it works is simply a server, um, and it has two basic endpoints, a couple of verbs for each, but basically two endpoints. And the first one is just pushing memory, right? So if you have this client application that is running chat, you can simply start to push messages or list of messages, and Motorhead receives those messages. We store them in a list, and as the list grows, we can currently verify if the list goes beyond a max window size, then we remove half of the messages and we incrementally summarize. And the way it works is it's happening really on background threads and all of this, and it's really scalable in the way that it has been built. Non-blocking calls. It's also generating the summaries with a prompt that you can specify yourself, and is using Redis under the hood for all the storage layer. And the reason that we use Redis is that we also vectorize each message, and we sort it in a vector index that Redis provides, and that then allows us to expose a retrieval endpoint, right? So retrieval really becomes uh, useful because now you can combine multiple of those techniques. So you have incremental summarization, which is pretty scalable, and then you also have retrieval if you want longer term memory. And so you play around with these different techniques. Ideally, you would. depending on your use case, you would select one for shorter term memory and another one for long term memory, and then adapt them as you go. If you have any questions or you want to contact us, please don't hesitate to do so. You can contact us at founders@getmetal.io. And yeah, thank you.
Yeah. Thank you for this presentation and overview of how we can uh, use memory and what technique we can use for uh, have more memory and send more information to LLM. Sergio, thank you for your presentation and thank you for all who was with us today. See you next week on next webinars. Uh, Thank you.
Thank you so much.